Network analysis. By the end of the lesson, you should be able to understand the concept of networks and network analysis, types of models in network analysis operation, application of network analysis. Network analysis is an operation in GIS which analyzes the data set of geographic network or real world network. Network analysis examines the properties of natural and man-made network in order to understand the behavior of flows within and around such networks and locational analysis. It focuses on edge node topology to represent real life networks of information. It functions based on the mathematical subdiscipline of graph theory and topology. Network analysis is basically a set of connected lines. These lines represent railways, streams, roads, water lines, pipelines, telecommunication lines, etc. that normally need to be analyzed as a network. It can be direct or indirect or planned and unplanned. Network analysis, the movement of people, connectivity and accessibility of railways, roads, pipelines and telecommunication, flow of matter and energy and movement of goods and services. Any type of network is connected by vertices and edges. This network is measured by compared by plotting of graph and linkages of object or features. Network depends on topological properties, that is connectivity, adjacency and incidence. Network analysis holds a prominent place in geographic information system. This is reflection of the earliest GIS data models that were implemented, its broad usefulness across domain areas and its potential for future development. The fact that network analysis was a significant component of scientific geography during the quantitative revolution in geography in 1950s led to its rapid introduction into GIS as analytical tools were added to the growing suite of functionalities in GIS software. Given the extraordinarily broad set of application areas that can take advantage of network structure, the use of networks in GIS has grown and networks are likely to remain a dominant spatial platform for analysis in the foreseeable future. While network analyzed in geography can be of great variety as road network, river network, utility network and more. It is the similarity in the structure that rather than the diversity in the application that truly provides the value for research and practice. Networks represent a fundamental spatial domain in which many phenomena can be located and over which many activities move. Network analysis can be regarded as a set of techniques with a shared methodological perspective, which allows researchers to depict relations among actors and to analyze the social structures that emerge from the recurrence of these relations. The basic assumption in that better explanation of social phenomena are yielded by analysis of the relations among entities. This analysis is conducted by collecting relational data organized in matrix form. If actors are depicted as nodes and the relation as lines among the pair of nodes, the concept of social network changes from being a metaphor to an operative analytical tool that utilizes the mathematical language of graph theory and linear assumption of matrix algebra. Types of operations: shortest path analysis, best route, closest facility, allocation, location allocation, OD cost matrix, network partitioning. GIS networks are algorithm of interconnected lines termed as edges and intersection termed as junctions. It works as a path for movement of people, goods and services. The object navigating the network follows the edges and junctions appear when at least two edges intersect. Junctions and edges can have certain attributes affixed to them that increases the cost of travelling in the network, known as impedance. For example, a road network can have speed limits attached to the edges, and a junction can prevent left turns. Networks are either directed, only one direction of travel is allowed within the network, or undirected, in which any direction of travel is allowed. Network can be a set of linear features through which resources flow. Nodes, the endpoints of lines, are used as origins and destination, and links, that is lines, traverse from one node to other. Nodes can have properties, but in network analysis, we are usually more concerned with the characteristics of the links. Lorenny and Thompson in 1992 said these include length, direction, connectivity, lines must connect at least 2 points, and pattern. Rivers flow the direction of downhill. It is the best example of an oriented network. The road connectivity can be either oriented or unoriented, that is, one way or two way, and usually roads contain loops. Trains usually travel in both directions between stations. One track, the railway network with smaller lines represent as unoriented. Somewhere else in the network, lines designated for travel in one direction only for the safety purpose. Two-track network are represented by a pair of oriented links in the network, can be either an unoriented or unoriented network. The direction of network or their link can have other properties that represent a cost of moving along the link. For example, nodes can have properties that might encourage or discourage travel in that direction. There are 5 most common types of network analysis. First, point-to-point analysis. A point-to-point analysis is the most common routing problem. It consists of a set of points to find the most optimal route based on the specific criteria, like find nearest, where the closest destination. It finds the nearest destination based on the starting point with multiple potential destinations. Shortest distance. What's the fastest route? This analysis accumulates all distances as you travel out from one point to another. Then it finds the route with the least distance, fastest route. Which route takes the least amount of time? This network analysis takes into account speed limits, road classification and other costs to determine the least travel time. Other type of point-to-point analysis include most eco-friendly, scenic and winding routes. Each type of network analysis generates directions from origin to destination. Finding coverage. In this type of network analysis, drive time areas corresponding to a distance that can be reached within a specified amount of time. For example, service areas. Which houses are within 5, 10 or 15 minutes from a fire station? This type of network analysis also can understand where businesses cover and if there are any gaps. Another one, drive time areas are different from buffers because it takes into account a street network. Buffers can cross water bodies, but a drive time areas can only cross water when there is a bridge. Optimize fleet. This tool is ideal when your main goal is to service a set of orders in traveling salesperson problem. Also, you can best minimize the overall operating cost by managing set of vehicles and drivers. The purpose of this network analysis tool is to find the most efficient route for delivery, repair, transit or any type of fleet services. For example, a furniture company might want to use several trucks to deliver furniture to homes. Alternatively, a fleet might want to schedule their weekly visit including all the logistics. Select optimal site. Optimal site selection takes into account the demand to locate the best location given several facilities. For example, it can help in deciding where to build new hospitals depending on existing hospitals and the available demand. Location allocation. This network analysis tool helps business owners pinpoint the optimal location for their store. It can also compare with competing stores to target market share. Origin destination. OD cost matrix. In ArcGIS, this is the OD cost matrix which measures the least cost path from multiple origin points to multiple destinations. OD cost matrix, this type of network uses two sets of locations to find the distances between all of the locations in two sets. For example, it can list the routes and direction for all stores and warehouses. In emergency dispatching, one set of location consists the incident and the other set is all the available fire station. Network model in GIS. Network model in GIS have the potential to simplify the development of spatial analytical network functions through various types of data model. Many types of data model are transportation network or road network utility network and stream network. These network function helps in planning, development and accessibility. Transportation network or road network. It includes roads, railway lines and flight paths. It is generally undirected network because the edge on a network may have a direction assigned to it. The transportation route, the direction, speed, destination of the travels can be decided by the person. For example, person in a car traveling on street, transportation or road network model play a key role in transportation planning, analysis of retail market, measurement of accessibility, allocation of service and more. The understanding of road network pattern provide the idea about the human mobility behavior. Utility network modeling. It includes water mains, sewage lines and electrical circuits. These networks are generally directed. Its path is predetermined. It can be changed but not by agent. Stream network. It includes flow of stream in catchment. It is directed network because of the natural flow. In this type of modeling is performed for the analysis of drainage based on terrain or digital elevation. It shows the detailed information about the connectivity of landscape and land use and land cover patterns. Stream network model analyze the geometry, that is shape, size, drainage density, landforms, etc. It helps in understanding the dynamic behavior of river flow that reduces the impact of floods and helps in socio-economic conditions of humans, supply of hydroelectric energy, etc. Shortest path. It is a common type of network analysis. It helps in finding the shortest path between 2 points. In a network of streets, the shortest route is analyzed for different variables, that is distance, time and monetary cost in terms of purchasing travel tickets or transportation of goods and services. For example, an ambulance driver looks for the shortest path to his destination for travel the route assigned to him or her from point A to point B in the least amount of time, the fair price of purchasing the plane tickets, etc. Traveling salesman. Sales always travel in order of network of market. It is the most efficient way to reach the market and sell the product. The network path of the salesman depends on quickest time in reaching the market, product demand of the market, and the correctness of the market. For example, an Amazon agent has to deliver a product in an area. He will follow the path of the first route of demanding product and the quickest time of the network route. UPS uses a traveling salesman algorithm to professionally deliver as many packages as possible to their customers every day. Network partition. Network partition refers for the subcategorization of network for particular purpose. The size of the network region depends on the proximity to specific point in the network. For example, coverage area of fire station are divided in metropolitan regions. The network of Indian Railway network divided in many zones as per regional proximity of states. Transportation model. Other basic functions, that is buffer, overlay, query, already exist in GIS operation are useful in planning transportation. However, there is many model available for the detailed or in-depth analysis of network data is available for planning applications like network flow, equilibrium models, travel demand models, trip generation and distribution, as well as activity based models and transportation or land use interaction models. Skilled programmers should be able to design programs to perform these tasks where software is inaccessible or non-existent. GIS is key for analysis of these type of transportation models. Network analysis workflow. In order for you to perform a network analysis in a GIS program, there are basic steps to be followed. The general procedure to do before you solve network analysis network problems. Organizing the network analysis setting. In any GIS system like ArcGIS, you need to enable the network analysis extension. You also need to display the network analysis toolbar before you can perform any analysis. Adding a dataset to your GIS program. Before you are able to perform a network analysis, you need to create a dataset network in which you can perform an analysis. There is no one available, the original reference source has been modified or has been changed, you need to build a new one. Creating a network analysis layers. Layers contain an in-memory classes where input, properties and results can be stored. In the case of performing network analysis, the layer has to be connected to a network dataset. This layer has to be created and added to the dataset before the analysis can be performed. In ArcMap, a network dataset must be added first so that when an analysis layer is created, network analyst can bind the analysis layer to the network dataset. The 6 kind of network analysis layer in ArcGIS include route analysis layer, closest faculty analysis layer, service area analysis layer, origin destination cost matrix analysis layer, vehicle routing problem analysis layer, location allocation analysis layer. Inputting network analysis feature and records. This step has added features or objects to our dataset input. Network analysis objects are features and records used as input and output during network analysis. These objects can include barriers, routes, facilities or other man-made structures that will influence the end analysis. When you add these objects, setting the properties to the network analysis layer will further define the function of the input. Performing the analysis. After you have finished the other steps of the procedure and created your layer, it is time to perform the network analysis. This can be done by clicking the Solve button on the network analysis toolbar you set up earlier in the process. Your results will then be displayed on the map and double click the network analysis objects in the network analysis. In GIS, networks are used for more than just finding shortest routes. Resource allocation, isochronous construction and many other operations require network data. Routing. Finding shortest route is probably the most common routing problem to occupy GIS user. Finding the shortest route from A to B through a road network is crucial for emergency services, business journey or simply planning routes for holiday makers touring a region. In order to carry out such operations, it is important to construct an appropriate network. Detail of connectivity, one-way streets, possible turns and speed limits will be required. There are a few features that are commonly encountered on a road network which may present problems, for example, streets with different access permission or turning restriction. Some of these can be modeled using the type of system mentioned. The network should also be capable of taking new information and recalculating the routes. Scope of network analysis is immense, but there is a gap between the demand and supply for network analysis operation. At present, most of the GIS software have capability for calculating the shortest routes only. Some may allow calculation of shortest route based on travel times, but most will stick to the shortest distance. Whereas, the more sophisticated network model will allow the addition of attributes such as speed limits, turn restriction and demand to make the operation more realistic. As the market for the in-vehicle navigation is growing, the technology is attempting to combine GPS and network analysis technologies with an dedicated set of products and services. Network is a set of connected lines and can represent rivers, roads, water line, telecommunication lines, etc. Networks can be directed and undirected, planar or non-planar. In GIS, networks are widely used for two kinds of modeling, transportation network and utility network. In addition, network analysis analyzes the way goods can be transported along these lines, that is telecommunication lines or road network, etc. Network analysis can be done in raster or in vector. Different type of operations include closest facility allocation, location allocation, origin destination cost matrix and network partitioning. Software industry has to facilitate more menus related to network driven operations, especially when the demand is for the real time functions dealing with big data. Network analysis is a set of techniques derived from network theory, which has evolved from computer science to demonstrate the power of social network influences. Using network analysis in domain analysis can add another layer of methodological triangulation by providing a different way to read and interpret the same data.